All right, today we're going to start section 2.1 in the pre-cal, or algebra 3, but pre-cal for us, instruction. This is functions, and mainly what we're going to talk about today is what is a function and how to identify the domain and the range of a function. If you have a function, for every member of the domain there is one member of the range. And so what that basically means is that all your input values of your x values have to be unique. They can't be repeated. And so we're going to go here and fill in some of these vocab terms. The domain, right here, the domain of a function is the set of all x coordinates on the graph. It's the independent variable. So independent is the x variable, and it's the input. Well, let me erase that since I can't write. Well, my eraser's not working. Okay, so I'll write it over here. It's the input. Okay, it's what you put in, and then you get an output. And that output is the range. Okay. Your output is the range. So this is your x, and the range is the output. So that is your y, or in function notation, y is the same as f of x, or it could be g of x, h of x. Every function might have a unique name. The zeros, or the roots of a function, sometimes this will also be called solutions. Zeros, roots, solutions are all words that many times are used interchangeably, so watch out for that. Okay. The zeros, roots, solutions of the function are the x-intercepts, or in other words, wherever it crosses the x-axis. Okay, so the x-intercepts are the roots, and that is, as a point, it's where y equals 0. Okay. Now, every set of ordered pairs is not a function, but they all are a relation. A relation is just a group or a set of ordered pairs. Now, every relation is not a function, but every function is a relation. So in function notation, if we have the line, and we know it's a line because the highest power of x is x to the first, in this case, f is the name of the function. F of x is the value, is the y value for a given x. So in other words, f of x is y. Okay. And to be a function, again, we're going to put a star here. To be a function, the x values cannot repeat, or do not repeat. Okay. Now, on these practice problems here, for the following relations, identify the domain, the range, and whether or not the set is a function. Alright, so the domain is all the x values. You typically write them from least to greatest, and if they repeat, you only write them one time. So this would be -8, then -5, -4, and -3. Okay. The range, that's a very bad bracket. The range is 0, 1, 2, and 6. Let's see if I can do a better job there. Okay. So we had 5 points, 1, 2, 3, 4, 5, but we have only 4 numbers in the domain and range, and that is because, if you look here, the -3 repeats, but we only list it once, and in the y values, the 1 repeats, but we only list it once. Is it a function? No, it's not a function, because we just said that the -3s are that we have 2 x values that are the same. So let's look at number 2. The domain is -6, -5, -4, -3, -2, and -1. Okay? And the range, looking at the y values, going from least to greatest, is 1, 2, 3, 4, 5, 6. Okay? Now the function, is it a function or not? Look at all the x's right here, not the y's, just the x's, and then none of them repeat, so yes, it is a function. Alright, number 3, the domain is -5. Again, put them from least to greatest, -1, then 2, and 3. And the range, the y values, looks like there's only one y value, so I only put it in there once, and it's 5. Now, all of them have the same y value, but they all have different x's. So yes, that is a function. Now, one thing you may see on some of your standardized tests, I don't know that you will, but I'm going to draw it here. This would be called a mapping. If you have a mapping, you list your x's inside this little chart. Okay, and you list your y's over here inside a little chart, and I didn't really make it big enough, so I'll get down here where it's bigger. And then you draw arrows. And in this case, all the arrows would point to 5. But if they, on one of these others, they would all point to whatever number they corresponded with. And you can read points from that mapping. But that is called a mapping, in case you ever see something like that. And that's what that means. So let's go to our next page here. And let's see what we're going to, this is probably going to, all the should disappear. I need to go to my mouse, make it a mouse. Okay, move it down to the next page. Alright, and this is going to be analyzing graphs. So we're just going to look at the graphs. And hopefully you've copied these off of the website, so you're looking at these up close rather than just on the screen. For the domain, sometimes people like to use sticky notes and cover up just to the left and right, and you've got to find the values of x that go with these. And now my vision is a little not that great, so it's possible I could miss some of these numbers, but let's look. It looks like the lowest x right here, if you read down, and here is your, you can see the arrows, there's your x-axis and here's your y-axis. If it looks like your lowest value of x is a -5, and your highest value for x is a 7. Now I want you to look at the circles on the endpoints of that line. On the left, right here, is a closed circle. That means it includes the 5. And the x can be any value between -5 and 7. So x is greater than or equal to, because it's a closed circle, -5, and it can go all the way to 7, but because this is an open circle here, it doesn't include 7, so it's less than 7. Now looking at the range, this time we're looking at the y values, remember, so our lowest value of y is right here, and we read over and we say that's at -1, and our highest value of y is up here, so we read to the y-axis and we find that the highest value of y is 5, and y is between then -1 and 5. Alright, so there's an open circle at the -1, so the less than sign goes there. And that's not a negative, that's just a mark I put on there. And then this is less than or equal to 5 because of the closed circle. Zeros, where does it cross the y-axis, the x-axis, excuse me? It crosses at 5, 0, right here. Crosses at 5, 0, right in there. Now, is it a function? You remember you can do the vertical line test. You run your pencil across and see, does it cross that anywhere in two places? And the answer is no, it doesn't, so it is a function. And y'all should be pretty familiar with vertical line tests by now. That should be nothing new. Alright, so let's look at number 2, the domain and range. These arrows indicate that this line goes to infinity. And it's going down and to the left here. So just at the domain we use the left, not the down part. So it's going to the left all the way. So that one's going to be negative infinity. Okay. And this one goes to the right all the way to positive infinity. Now the next lesson is interval notation, so this we really don't necessarily know. So if you don't know interval notation, you put all real numbers. Okay. And if you are doing set builder notation, you do x such that x equals all real. And that would look like this. I'm going to write it over here. X such that x is equal to all real numbers. And you put it in brackets. That's called set builder notation. Now looking at the range, obviously it goes down to negative infinity, and I'm not going to use that anymore because that's the next lesson. But it's up here at positive 6, so it's 6 or less for the y's. It's nothing greater than 6. So you would write y is less than or equal to 6. Okay? Or y such that y is less than or equal to 6. And you could say x is an element of all real. Alright, now zeros. It crosses the x-axis at -4. Remember, your zeros are going to be a point, not just a number, and at 4. Is it a function? Vertical line test? Yes, it's a function. Alright, now we've got this crazy squiggly looking line here. First we can answer, is it a function? Yes. Vertical line test, it never crosses the same, has two x values that are the same. Domain, looking down here, the lowest value is -5, and the highest value is up here, and that is at 6, positive 6. And x is, because it's connected with a line, it's not just a set of points, it's every possible number, fraction, decimal, whatever, between -5 and 6. They're open circles on each end, so we're going to put less than, less than. Now we've got a little bit of a problem here because this line is actually not continuous, because if you go down right here, you see an open circle. And that open circle is on 3. So that means it can't actually be, it's like a little gap in the line. X is not equal to 3. It's everything else but. Since this is a closed circle, it's okay. It can be that. But it can't be this down here, the 3. That should be -3. -3. X can't be -3. Now looking at our y's. Okay. Looking at our y's, the x value here was 3, but the y value on this one is -4. So -4 is our lowest point. And we have a y. And the highest point is 6. Okay. Now, I want you to notice, this is an open circle, but it doesn't exclude this 0 value, because this line goes through it. So that means it's still, because even where there's these open circles, this part of the line actually includes that value. So you don't exclude a value in the range. The range is going to be -4 is less than, because that's an open circle, y, which is less than or equal to 6, because that's a closed circle. And these don't matter because of this line right here that includes those values. And that's a little tricky. I'll admit that's a little tricky. So watch out for those. Okay, domain. We have a circle. There's nothing excluded. There's no open circles along the way anywhere. So we're going to go, the lowest x is -4. The highest x is 4. and it's all included, so it's less than or equal to. So x goes from -4 to 4, and circle, the radius is going to be the same and the center is at the origin, so the y also goes from -4 to 4. And our zeros, I forgot to do those on the other one, are -4, 0 and +4, 0. It is not a function because obviously there's a lot of places where the x's are the same. It doesn't pass the vertical line test. Let's go to this one and reread. This zeros are at 2, 0. Okay. And again, the one here doesn't count as a 0 because that's an open circle. It never gets there. The only 0 is right here, and then again right here, which is 5, 0. So that was a tricky one. Number 3 was really tricky. You might, kind of go back and rethink and look at that. Okay, I'm going to go to the last page. There's 2 more, I believe. So we're going to get off of this and move down to the last page. Get my pen back. All right, here we have, it says sketch the graph. And there's first of all, you need to know that there are multiple possibilities. You may not all have the same graph. And the next thing is make a box. And that might help you to draw your line or your shape, whatever. All right, so let's first look at our domain. X is less than or equal to 3, so we're going to go here at 1, 2, 3, and I'm having trouble seeing right there, I think. Okay. And Y is 7. 1, 2, 3, 4, 5, 6, 7 right there. Excuse me, X is so in other words, X has to be no less than 3 and no greater than 7. And it includes both 3 and 7. And we have Y is +1, so it actually doesn't start till here. And it goes up to 10, which is up here. So now let's make a box that sort of includes, and I'm going to sort of kind of just do dots. I'm going to draw a box and go up here, see if I can get dots to show, and go over here all the way to 7. Okay, so that's a box. Now you could do the corners of the box if you wanted to. The corners of the box are at 3, 1. That's right here. They're at 3, 10. They're at 7, 1. And 7, 10. Oh, and I put it at -3 instead of +3, so that's a mistake. So let me fix that. I don't know why I put it at -3. So we go here to 1, 2, 3. Okay, so we're going to have this sort of box right here. That's the way our box should look. Sorry about that. So now it includes those points. Now you could, so we know our end points are going to be solid dots because they were all right here and right here. Okay, you could have put it this way if you wanted to. It would still work. You could draw a straight line. You could draw some sort of squiggly line. It doesn't matter. But it has to go from 3 to 7, including the endpoints, and from 3 to 7, including the endpoints, and from 1 to 10 in the y direction, including the endpoints. It could be a straight line. It can be some sort of crazy line. But you have closed circles on each end. Now let's look at this one. We go from x is 2. So here's x is 2 right here. There's my y. So right there is x is 2. And we go to 8. Okay. And then we go from -1, which is right here in the y value, up into 6. So we go 1, 2, 3, 4, 5, 6 right there. Okay, so let's kind of draw our box. And if I'm off a little bit, I'm sorry, I have trouble seeing the grid on the screen. But you draw a box. And your corners of your box, boy, you can't even read that. That's pretty pitiful. Let's try again. The corners, okay, still hard to read, but anyway, hopefully you heard. The corners of the box are at 2, 6, at 8, 6, at 2, -1, and at 8, -1. Okay? So let's look now at our inequality. 2 is less than x. Okay? And -1 is less than y. So here at 2, -1, we've got to have an open circle, because it can't include that x or that y. Now looking up at the 8, over here at the 8, x can't include 8, but it does include 6. So we've got to kind of have 2 points for that. So you can put a point here somewhere, it doesn't matter where, at your x equals 8. Okay, so I've got 2 is less than, for my x's, I've got a point at 2 and I've got a point at 8. Neither are included. Now looking at the y, at -1 I have a point and it's not included. I'm going to have to put a point somewhere up here for 6 that is included. So my graph has to hit the 6 and it has to be included. So this is a place, this is one where you really need to watch or be careful. Okay, because this has a little extra twist to draw in this graph. Again, it's not, it could be multiple graphs. You could have different shapes, but this will work. And so I could draw a straight line from here and a straight line down here, or a curved line if I wanted to. Okay, so again, that's not included, this point's not included, this point is included. So you could have a curved line, straight line, but it needs to be sure that those endpoints are met, and the named traits, or whatever you want to call them, of the domain and the range. Okay, that's it for 2-1.